This is another example of how to use the fundamental theorem of calculus. So just a reminder, we use the fundamental theorem of calculus when we're evaluating an integral from point A to point B. So just a reminder over here of what the formula is. It's the integral from point A to B of small f at x dx. You're going to evaluate the antiderivative at point B and subtract the antiderivative evaluated at point A. So we can start with our antiderivative now. So for the first term, we have sine x, and the antiderivative of sine x is negative cos x. So for that first term, we're just going to write negative cos x. And for the second term, we have a constant. So the integral of a constant is going to be the constant multiplied by x. So for that next term, we're going to have plus 2x. And we're evaluating this from 0 to pi over 2. Once again, you don't have to add your integration constant. So now we can start to plug in our values. So first we have to start with our b value. Your b value is always your top value, and your bottom value is always your a value. So if we plug in the b everywhere we see x, we're going to get negative cos pi over 2 plus 2 times pi over 2. And now we're going to plug in our a value. So we have minus cos 0 plus 2 times 0. And now we can start to simplify this. So cos of pi over 2 is actually 0. So if it's negative 0, so it's just going to be 0. And 2 times pi over 2 is just going to be pi because those 2's cancel out. So this term is only going to have a pi in it. For the next brackets, we have minus cosec 0 plus 2 times 0. 2 times 0 is just 0, so we don't have to worry about that term. And cosec 0 is actually 1, and since there's a negative out front here, it's going to be negative 1. So this whole term is going to go to negative 1. So for this, since we have minus negative 1, it's going to turn into plus 1. So that can't be simplified anymore now. So now we can write our final answer. So therefore, the integral from 0 to pi over 2 of sine x plus 2 dx is equal to pi plus 1.